Okay. We're doing this video on least common multiple. It's video number 20. Okay. We already have 19 videos. Okay. Let's continue. We talk about what is LCM is. LCM is least common multiple. Okay. And we'll try to compute that using in next section using factors. The next section would be we'll compute LCM using divisions, using else compute LCM using vertical and crosswise. By the way, division are same thing as factor. Okay, so another way to say factors. Let's continue here. So what's LCM good for? Let's see. Can we use that someplace? Okay. What do we need LCM for? Okay. Answer: we use it everyday life. Okay, we use it in everyday life. Let's continue here. Here example: Ben exercises every 6 days and Sen exercises every 4 days at a gym. Both exercise today. After how many days would the two exercise together next? Okay. If exercise like that, if Ben and Sam are good friends and they met today at gym and they come in every 4 days and every 6 days, Ben comes every 6 days and Sam comes every 4 days, they want to know, hey, when would be the next time they would meet again at the gym? Okay. Let's continue here. Example: Linda and Paula are cycling around a track. Linda completes one track in 15 minutes and Paula in 10 minutes. Both started at 8:30 a.m. from the start point at the same in the same direction. When would they meet next at the start point? So question like that would require a LCM. A radio station gave away $100 bill for every 100th caller. Every 30th caller received a free concert tickets. How many callers must get through before one of them receives both a $100 bill and a concert ticket? Let's continue here. What's LCM? What's LCM? It's a least common multiple. That's what it stands for. Okay. So, so it is a multiple. It's multiple of a number r, n are like 1 times n, 2 times n, 3 times n, and so on. So it's a multiple. Then it's a common multiple. Common multiple. The multiple is common to all the numbers in question. All the numbers are factors of this multiple. So the multiple is common to all numbers. Okay, if when there's some number is multiple of a numbers, that those numbers are factors. Okay, let's continue here. And then least common multiple. We are interested in one multiple which is smallest, least of all the common multiples. Okay, so in here 2 times n, 3 times n, 1 times n is smallest. So that's what we're looking for, the least one. Let's continue. Just like HCF, we will use factors and multiply these factors. However, we are looking for a multiple. So we will need to use all the factors common to all or common to fewer than all numbers. Let's continue. Okay, now we talk about how to compute LCM using factors. Okay. So let's compute LCM using factors. Okay. Question: what are we looking for here? We're looking for least common multiple. We'll use divide and conquer again, and this method is we do factors, identify factors common to all the numbers, multiply all common factors, and this is my HCF. Okay, so far we have done that in the previous video. Okay, identify factors common to fewer than all, multiply this HCF number with these common factors, okay, multiply with any remaining factors which is common to only one. Okay, and note, literature might suggest that use prime factor. We will just go ahead and use the factors we can think of and then convert these to prime factors if desired. Okay. Now we'll compute LCM example. Example is from an online PowerPoint presentation. Okay, so what's HCF of 8 and 12? Okay, let's find out. We are going to do the factors here. Are both numbers even? Yes. We're trying to find out what's common factor here. 2 is a common factor, so that means that the two numbers are 8 is 2 times 4 and 12 is 2 times 6. So 2 is a common factor here. Are 4 and 6 both even again? Yep. So yes, and 2 is factor again. So 8 is 2 times 2 times 2 and 12 is 2 times 2 times 3. Okay. Now these 2 and these 2 are common factors, and these 2 and 3 and we go to think about next. Let's continue here. So 8 is 2 times 2 times 2 and 2 times 2. 12 is 2 times 2 times 3 and 2 and 3 don't have any more common factors. Okay. So do 2 and 3 have any common factors? This 2 number 2 and number 3 here? Nope. Okay, so HCF is 2 times 2 this common factor, and LCM is 2 times 2 times this 2 and this 3, which is are not common factors. Okay? So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. Let's continue. We use product of all common and not so common factors to find the least multiple common multiple. Let's continue from here. Example continue. So this is another example here. Okay, it's a radio station gave away $100 bill for every 100th caller, and every 30th caller received free concert tickets too. How many callers must get through before one of them receives both a $100 bill and a concert tickets? Okay, let's continue here. Here we're looking for the first, which least number caller who receives both a $100 bill and concert tickets. Let's continue from here. So first thing we're looking for, are there any common factors in 130? Okay. So we're looking for LCM of 130, and we know that we need to get all the factors, common and not so common factors. Okay. Yes, 10 is a common factor. Okay. Let's continue here. So 100 is equal to 10 times 10 and 30 is equal to 10 times 3. Okay. So this is my common factor and this is my not so common factors, 10 and 3. Okay. Let's continue here. So HCF is 10. HCF, this is my common factor. There are no more common factors here. 10 and 3, I don't have a common factor. Okay, and no, not so common factors are this 10 and this number 3. Okay, let's continue here. LCM is HCF, which is 10 times the not so common factor, 10 and a 3. 10 and a 3. Okay, which is equal to 10 times 10 times 3, which is equal to 300. So 300th caller would receive both a $100 bill and concert tickets. Do another example here. This time we will do LCM of 70 and 90. Let's continue here. What's the LCM of 70 and 90? We'll use the list method here. So we'll make a list of multiples of 72 on the left side and those of 90 on the right side. Okay. So we get 72 times 1 is 72, 72 times 2 is 144, 72 times 3 is 216, and of 4, 288, 5, 360, and 6, 432, and so on. Okay. Let's do multiples, a few multiples of 90 and see if there's any match. Okay. 90 times 1 is 90, 90 times 2 is 180, 90 times 3 is 270, 90 times 4 is 360. At this time there's a match. 360 is a multiple of 90 and 360 is a multiple of 72, and this is the first or least multiple we found so far. Okay, so this is our answer. Let's continue here. So 9 times 4 is 5 is 450. Okay, we don't need to go that far, but that's okay. Let's continue. And then we have 90 times 6 to 540 to see that this is the only matching multiple so far we got. Okay, and this is the least one. This is the first one. We say 1 2 3 4 5. We use the smallest multipliers here, smallest multipliers here. So very first least multiple common multiple is 360. Okay, that means LCM is 360. LCM of 72 and 90 is 360. Let us continue. Compute LCM of 275, 675, and 950. The same numbers we had used before in computing HCF. Okay, let's continue here. What's LCM of 225, 675, and 950? Okay. But do you notice any common factors? We know that 25 is a common factor because this first number ends in 25, second number ends in 75, which is multiple of 25, and third number ends in 50, which is also multiple of 25. Let's continue here. Yes, that's a 25 is the common factor. Okay. So the numbers are 25 times 9, 25 times 27, and 25 times 38. If you need some time, please think about it, and you can verify that that's true. That these 225 is 25 times 9, 675 is 25 times 27, and 950 is 25 times 38. Let's continue. Do you notice any other common factors? Okay, 9, 27, and 38. Okay, 9 and 27 have a common factor 9, and 38 does not have the same common factor. Okay, not all common to all, but however 9 is a common factor of the first number 9 and 27. Let's continue here. So numbers are 25 is a common factor to all, and 9 is a common factor to two numbers. Okay, now we have numbers 3 and 38. Okay, those are odd numbers so far. Okay, so are the common factors of 3 and 38? Nope, they're no common factor. They're not both even. They're not both divisible of 3. Okay, let's continue. HCF is 25. That's the common to all the factors in all the number 25. Okay? And LCM is 25 plus factor common to 2, 9, and factor not common to only one number, 3 and 38. So that would be equal to 675. 25 times 9 is that number 225, times 3 is 675, like that. 225 times 3 is 675, and times 38. So we'll do that. 38 is 40 minus 2, and we will do a 2 times 20 minus 1. 38 is 2 times 19, which 2 times 20 minus 1. We'll do that. Try to figure out a easy, simpler way to multiply. Okay, so that is equal to 675 times 2 is 1350. We have done a video on doublings, and times 20 minus 1, 27,000, which is equal to minus 1350, and which is equal to 25,650. We have done all from 9 and last from 10 type 2 subtractions before. Okay, so LCM is 25 times 9 times 3 times 38, and which is equal to 25,650. Okay, let's continue. Okay, let's go LCM of 1350. Okay. A teacher teaches two classes, and one has 30 students and the other has 50 students. What's the minimum number of pencils the teacher needs to carry to distribute evenly to either class? If a class of 30 shows up, teacher should be able to pass out the pencils in evenly distribute them. If the class of 50 shows up, it should have no issue in distributing the pencils evenly to all the classes. Okay, let's continue, all the students. Let's continue here. So we are looking for LCM of the least smallest number of pencils, minimum. Okay, least LCM is 30 or 50. That's what we are looking for. Okay, let's continue. Do you see any common factors of 13, 15? Sure, we have see 10. Yes, it is 10. Let's continue here. So numbers are two numbers are 10 times 3 and 10 times 5. 30 is equal to, first number is 10 times 3. Second number is 10 times 5. Let's continue here. Do you see any more common factors 3 and 5? Nope. There are no more common factors. This 3 is divisible of 3, and 5 is not divisible of 5, and 5 is divisible of 5 and not by 3. Let's continue. So HCF is 10. That's a common to both numbers, and LCM is HCF, which is 10 times not so common factors 3 times 5. 10 times 3 times 5 is 150. So LCM is 360, 150. LCM of 30 and 50 is 150. Let's continue here. Teacher needs to carry 150 pencils. So we're looking for how many pencils the teacher needs. So if the teacher has 150 pencils, he might face a class of 30 students or the class of 50 students. she will be able to distribute the pencils evenly. Let's continue from here. Now we have done HCF of these two numbers before. Now we will do LCM of these numbers. 142,857 and 9999. Okay, let's continue here. What's LCM of, well, this equation 142,857 and 999999. Okay, let's continue. Do you notice anything special about first number 142,857? The two parts of 142,857 and 857 are 142 plus the two parts are 142 and 857, such that 142 plus 857 is 999. Okay, so and that must be, it means that it is equal to 143 times 9999. That number must have come from multiplication by a sequence of nines. Okay, let's continue. And we discussed that in this video, multiplication by sequence of nines, and the video is that one. Okay, let's continue. Do you see anything special about this number 999999? That sequence of nines first, another sequence of nines again, three nines and three nines. Okay, first three digits and last three digits match. Okay, the two parts are 999 and 999. The two parts are equal. Okay, the two parts match, we just said. Okay, let's continue. And let's look at how do we get two matching parts. If I say 11 times 3, I get 3 and 3. If I 101 times 67, I got 67, 67. That is a sequence of zeros guarded by two ones at the end, one on the left and one on the right. So 1001 times 253 is 253, 253. That's two zeros being guarded by one single digit one on left and single digit one on the left, right. Okay, let's continue. That means 999 and 999 is equal to 1001 times 999. That, what does it mean? 999 is a count factor here. Okay? Okay. The two numbers are 143 times 999 and 1001 times 999. Okay. So 999 is a count factor of the both numbers. Let's continue. Okay. So we already computed so far. Let's continue here. Do you see any common factors of 143 and 1001? Okay, let's continue here. Both are divisible by 11. This is divisible by 143 is and 1001 is. And this is the video we have. Divisibility by remainders. We did that, and it talks about some difference method here. Digit sum and digit differences. Okay. Let's talk about numbers are. So the two numbers are now 11 times 13. 143 is 11 times 13, and 1001 is 11 times 91. Okay. So we have a 11 is a count factor, 999 is a count factor, and this 13 and 91 we have to resolve further. Do 13 and 19 have a count factor? Both are divisible by 13 because 91 is equal to 13 times 7. Let's continue here. The numbers are 11 times 13 times 999, 11 times 13 times 999, and times 7. 11, 13, and 999 are common factors to both the number, and 7 is not the common factor. Let's continue. So far we have done that. So now there are no common factors. We have to multiply by all the common factors and not so common factors. So the HCF is the common factor 11 times 13 times 999, which is equal to 142,857. That's my HCF here. Okay, okay, and then let's LCM is HCF time product of not so common factor. Not so common factor is this number 7, which is not in this the first one. Okay, multiply by 1 does not make a difference to the results. Okay, let's continue here. So LCM is 142 times 857 times 7. Okay, and you can multiply them together, and that's 999,999. 9. That's the second number here. So HCF is the first number of, and in this example, and LCM is the second number. Let's see if we need to do a prime factors. Okay, let's continue. What's the LCM of 142,857 and 999,999? Okay, we already did that. The two numbers were 143 times 999, and this one was 1001 times 999, and which we further divide into 11 times 13 times 999. Is 11 times 13 times 7 times 999. Okay. Now, but we are caring for a prime factors here. Instead of doing the factors, we did 999 as common factor here, which is not prime. So that's what we do. If you really care for prime factor, we can continue from here. So 11 times 13, 999 is 9 times 111, and 9 times 999 is 9 times 111. I move the 7 to the right, which is not common. These two are, I just move the common factors to the beginning here. Okay, let's continue here. So 11 times 13, 9 is 3 times 3, and 111 is 3 times 27. And this is 11. Now the 7 here, 11 times 13 times 3 times 3, 4, 9, and 3 times 37. Okay, let's continue here. HCF is this common factor here other than 7. This is 11 times 13 times 3 times 3 times 3 times 37, and which is 143 times 9 times 111, which is equal to 143 times 999, which is equal to 142,857. Okay, now LCM. LCM is HCF times not so common factors, and not so common factor, only one factor is not so common, which is 7. Okay, let's continue here. So 142,857 times 7, okay, and which is equal to 999,999, and that is my second number. HCF of these two numbers is the first number 142,857, and LCM of these two numbers is 9, second number, which is 999,999. Let us continue. Now look, LCM of 27 and 99, 999. LCM of 27 and 999. Let's continue here. What's LCM of 27 and 999? Let's continue. Do you see any common factors? 2, 3, like 2, 3, 5, 7, 9, 11, which we know how to figure out. Okay. 9 is common factor of both the numbers, because the digit sum of this 227 is 9, and digit sum of 9 is also 9. The 9 is a common factor. Okay. Then my first number is 9 times 3, and second number is 9 times 111. Let's continue here. Do these numbers have 3 and 11 have 111 have any common factors? Yes, digit sum of both is 3. 3 digit sum is 3, and 1 plus 1 plus 1 is 3. They both are divisible by 3. Let's continue here. So the numbers are 9 times 3. First number is 9 times 3, and second number is 9 times 3 times 37. Okay. So 9 is a common factor to both, 3 is a common factor to both, and 37 is a factor only of the second number. Let's continue here. Do you see any more common factors? Okay. Nope, there are no common factors. So HCF is the common factor, product of the common factors to both the numbers. 9 times 3, 9 and 3, and it's 27. LCM is equal to HCF, which is 27 times not so common factor. 37 is a factor of only the second number, not of the first number. Not so common factor, which is it. So that's 27 times 37. 27 here and 37 that not so common factor. Okay. So which is, and 27 times 37 is like 9 times 111. Okay. We just split the 27 into 9 times 3, and 3 we multiply with 37, okay, and which is equal to 999. In Vedic math, we try to figure out any way we can simplify the problem. Here I know that 3 times 37 is 111, and I split that 27 into 9 times 3. Okay. So it's a 999. Another LCM example. Linda and Paula are cycling around a track. Linda completes one track in 15 minutes and Paula in 10 minutes. Both started at 8:30 a.m. from the start point in the same direction. They're both running in the same direction. When would they meet next at the start point? Let's continue here. What are we looking for? We're looking for next earliest time. Okay. How do they meet at start point? So if they start and when do they, how do they come back to start point here? Okay. Answer by completing whole tracks. After each completing whole track, they are at a, okay. So Linda's at start point. One is the Linda at start points. Okay, one is Paula at start point. We'll make a list of the when these two girls, Linda and Paula, are at the start points. Okay. Linda is start point 8:30 plus 0 minute. That's where start point is. That's where the first, they both take off. Okay. And Paula is also at same time 8:30. That's what the problem says. The start meet at both start 8:30 a.m. from the start point in same direction. Okay, let's continue. Okay, so Linda would be Linda takes 15 minutes to, so Linda would be there 15 minutes after also. Okay, and Paula would be there at 10 minutes after. Okay, now 15 minutes was more than 10 minutes, so we discover one more number here. So Paula would be there at 20 minutes after 8:30 also. Okay, let's continue. And Linda would be there in 30 minutes. In second, completes one round at 15 minutes, completes another round, another 15 minutes. That's 30 minutes. Okay. So now we look at where the Paula is. Okay, and Paula goes through the round here and gets 30 minutes. In the next, it completes one more round and gets back start point at 30 minutes. Now 30 minutes matches here and 30 minutes matches here. Okay, let's continue here. Do you see both this at start point at the same time again? Yep. That is 8:30 a.m. plus 30 minutes. 8:30 a.m. plus 30 minutes. 8:30 a.m. plus 30 minutes. Okay. Okay. The two meet at start point next at 9 a.m. 8:30 a.m. plus 30 minutes is 9 a.m. Okay. Let's continue. Okay. Let's just do some problems. Okay. For the LCM of the following problems, okay, LCM of 72 and 111, 12, 143 and 110, 15, 30 and 105, 63 and 27 and some more. Okay, let's get to next section here. Now we will compute LCM using divisions. Okay, factors and division are similar, so we'll use this method using divisions. Okay. LCM of these three numbers 192, 204, 272. Find LCM of 192, 204, 272. Method. We keep dividing all three numbers by common prime factors and by not so common factor. We'll do prime factors this time. Okay. Let's continue here. The three numbers are 192, 204, 272. Okay. We set up the division here like this. Okay. So do you see any common factor here? 2 is a common factor, so we divide by 2. We divide 192 by 2, we got 96. 204 by 2, we got 102. 272 by 2, we got 136. Do you see any common factors again? 96, 102, and 136. They're all even numbers, so we will divide. 2 is a common factor. We'll divide by that. So this is prime number here. Okay. Let's continue. Divide 96 by 2, we got 48. Divide 102 by 2, 51. Divide 136 by 2, we got 68. See any more common factors? 48 is divisible by 2 and also by 3. 51 is divisible by 3 and 68 is divisible by 2. Okay, so there are no common factors, more common factors now. Okay, but there are pairwise common factors though. So HCF is 2 times 2 equal 4. So this is HCF is 2 times 2 equals 4. Let's continue here. And at this stage there is no more common factor but which is common to all the numbers. However, there are pairwise common factors. Let's continue here. So we know so far there at this stage there is no more common factor which is common to all the number. However, there are pairwise common factors. Okay, and let's see what happened. And by divide by pairwise common factors 4. So we can divide by 48 and 68 have a common factor 4. We can do in 2 steps 2 and 2, but this time I'll just go take a shortcut and divide by 4. So now we are trying to find a not so common factors. The factors are common only to fewer than all the numbers. Okay, so 4 is a common factor to both 48 and 68. Let's continue here. Okay, note that again 4 is not a common factor. I could have done in 2 steps 2 and 2. I just chose not to do that. Okay, let's continue here. So it's a shortcut. Okay, let's continue here. So now we'll divide by 4. When divide 48 by 4, I got 12. 51 is not divisible by 4. We just keep 51. And 61 divide 68 by 4, I got 17. Okay, 17 here. Okay. Let's continue here. Okay. So we've gone so far now. The common factor 3 is of the first two numbers, not so pairwise common factor 3. So we divide by 3 now. Okay. Okay. When divide 12 by 3, it's a 4. When by 51 by 3, I got 17, and 17 is not divisible by 3. We'll keep the 17 here. Okay. So we got 3 is a common factor to the number 12 and 51 pairwise common. Okay. Let's continue. Now 17 and 17 have a common factor 17, which is pairwise common, not common to all. Okay, let's continue here. So we'll divide 17 now. Okay. 4 is not divisible by 17, we keep the 4. We divide 17 by 17, got a 1. We divide 17 by 17 again, got a 1. Okay, let's continue here. So continue with the problem of LCM of 192, 204, 272. Okay, we got so far 2 and 2 are the two common factors to all the numbers, that HCF, and 4 is a common factor of two numbers, 48 and 68. 3 is a common factor of first two numbers, 12 and 51. 17 is pairwise common of 17 and 17. Let's continue here. There are no more not so common factors anymore. These are all individual factors. Okay, so HCF is 2 times 2 is the product of the factors which are common to all the numbers. Okay. And LCM is HCF times not so common factor 4, 3, 17, and individual factor 4 and 1 and 1. Let's continue here. That equals 4 times 3 times 17 times 4 times 1. Let's continue here. That's a 48. 4 times 4, 16 times 3, 48 times 4 times 17. 48 times 4 is 192 times 17, and which is equal to I split 192 into 200 minus 8. Okay, and that's times 17 and times 17. Okay, is equal to 3400 minus 136, and we have done these subtractions before. All from 9, less from 10. 3264 is the answer here. LCM is 3264. Let us continue. Let's go next section here. We'll do a compute LCM using vertically and crosswise. Let's continue. This section is from Vedic Math for Schools, volume 3, and the book uses examples of LCM of two numbers only. Okay. Okay, let's continue here. In section we'll use this sutras, vertical and crosswise, and individual and universal. Okay, let's continue here. By the way, anytime we multiply or divide, we are using the proportional sutra too. When number has a factor, it's a proportional to that factor. Okay, let's continue. Determining factor is also determining proportionality. Example is LCM of 12 and 30. Okay, let's continue. Set up the numbers in the same way as we did for LCM by division. Okay, let's continue. So we did 12, 30, and we're trying to divide. Okay, the two numbers are divisible by 2, so we divide by 2. Okay, divide by 2, so we got 6, okay, and a 15. Okay, so 12 divided by 2 is 6, 30 divided by 2 is 15. Let's continue. Now two numbers have a common factor 3, so we will divide by 3 again. It's a multiple of 3, and this one is a multiple of 3. Let's continue here. So we divide by 3. 6 divided by 3 is a 2, and 15 divided by 3 is a 5. Let's continue here. The two numbers are now co-prime. 2 and 5 do not have any common factor other than 1. So they are co-prime, okay? Relatively prime. Let's continue here. LCM is crosswise product like 30 times 2 or 12 times 5. Let's continue here. LCM is 12 times 5, which is 60, or 30 times 2 crosswise, it is 60. 30 times 2. Let's continue here. LCM of 12 and 30 is 60. Let's explore it further. So we have done, so far we have done that. We try to find LCM of 12 and 30, and we, after dividing by common factors, okay, we got this form here. 2 and 3 are common factors, common to all the numbers, and 2 and 5 are the relatively prime numbers left. Okay, so let's continue here. According to Glover's book, the two common factors 2 and 3 are universal factors, okay? And the co-prime factor 2 and 5 are individual factors. Okay? HCF is product of universal factors. HCF is product of the universal factors. LCM is product of universal factors and individual factors, and so that is product of HCF times product of individual factors. Okay, continue here. So sutra used is here individual and universal. Individual and universal. Okay. Let's do another example. This time we'll do a 96 and 72. Find LCM of LCM as 96 and 72. Set up the number the same way as we did before. Let's continue here. Okay. Okay, let's continue. Okay, let's find out to divide two number by common factors. These two have a common factor of 8. Okay, let's continue. So divided by 8. Okay. 96 divided by 8 is 12. 72 divided by 8 is 9. Okay, let's continue here. They divide two number by common factor again of 3. 12 and 9 have a common factor 3. 3. So we still have universal factors here. Okay. 12 divided by 3 is 4. 9 divided by 3 is 3. 3 and 4 are co-prime. Okay. So, and no more common factors. Okay. So LCM is 96 times 3, which is 288, or 72 times 4, which is 288. Let's continue. This is okay. Let's continue. Some exercises here. Find LCM of two numbers 6314, 5236, 5916, 5304, 2457, 1593, 3051, 2599, 2163, 1827, 2343, 1947, 3182, 2408, 3969, 1029, 507, 2067. Hey, if you find like that little too complicated or too hard, just skip them. Okay, okay. And 7433 and 761. Let's continue. 2882 and 1474. Let's continue. Here is an example I encountered in 5th grade, maybe in 6th grade. Okay. In India, they have ladders. We climb from one floor to the next floor using ladders, and in some of the homes they still have ladders. Okay, and so they have steps on them, and if I scale the ladder going from one floor to the next floor in 2 steps at a time, in the end one step is left at the end. Okay, if I try to scale 3 steps at a time, I get 2 steps left in the end. Okay? If I get scale 4 steps at a time, the 3 steps are left in the end. How many steps does ladder have if the number of steps are between numbers 30 and 40? Okay. First of all, okay, we try to find out what the number of steps are. Okay, let's continue. And someone asked me this question here, and I said 35. Okay, and okay, so when the friend asked me how I found that, and saying, hey, I told him that was easy. You said number of steps are between 30 and 40, and number in right in the middle is 35. So that must be the number. Okay, all right. Well, let's say wrong approach. That's not the way to approach it. I know I got lucky that time, and I might have got lucky other times too, but that's not the way we do it. Okay, let's continue. It's LCM problem. Okay. Of course, we finally figured out how to solve that problem. Continue. Here's the problem here. Book figuring has a decent explanation, which a similar problem, a little more complicated than what we have here, but it has a decent explanation, okay, and which really clarifies how to approach a problem like that. Okay. First of all, let number of steps be x. Okay. I know some of the students in some schools would say that the x variable x or algebra is not allowed in 5th grade, but let's take that liberty here. Let number of steps be x. Let's see if we can use it. Okay. So then x plus 1 is divisible by 2. Okay. 2 steps are left in 1 step left. So if I add one more step to that, then means that it becomes 2 and then I have 0 left. That means x plus 1 is divisible by 2. Okay. Let's go for next thing here. If I scale 3 steps at a time, 2 are left. If I had a 2 plus 1 were left, then that would be 0 left after that. So we'll have a x plus 1 is divisible by 3. Then similarly from this next line here, I scale 4 steps at a time, 3 are left. If I had one more step, I would have 0 left. So x plus 1 is divisible by 4. Okay. Okay, so we know so far. So then x plus 1 is a multiple of 2, 3, and 4. Okay, is a multiple of 2, 3, and 4. Okay, and LCM of 2, 3, 4 is 12. Okay, we can LCM is 2, 3, 4 is 12. We can compute that. 2 is a common factor of the first two numbers, first and last numbers. So we get a 3 times 4 is the LCM 12. Okay? And the multiples x plus 1 must be is a multiple in 12, 24, and 36 and 48. Given our problem that number is between 30 and 40, this is the multiple we are going to use. X plus 1 is 36 to solve this problem here. That means desired value of x is 36 minus 1, which is 35. This is how we need to solve that problem, which I just solved 30 plus 40 divided by 2. Let's continue. We use that Bharti Granth book is the main reference to anything we do in Vedic math. The next is Discover Vedic Math by Ken Williams. This is most complete, authoritative, and consistent notations. The only thing is it's organized by sutras and not by the topics. Okay. And Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. They're easy to use, easy to read, very complete, contain significant geometry which I have not covered. Let's continue here. And I also mentioned figuring by book Figuring by Shakuntala Devi. Let's continue.